Hello, everyone. It's great to be back here again. So one question that have been asked a lot in the past few months by my friends, colleagues, peers, etc., is there are so many new developments happening. How do we figure out which one is actually a tangible improvement? Uh, so many dozens of new LLMs are out, especially in the open source arena. Which ones are actually good? Which ones? How do I measure whether one LLM is better than the other? How do I choose a particular LLM for my task? I'm not going to answer any of those questions here because I guess uh, none of those questions have a straightforward answer. But I can go through some of my thought process in how I reason with the new advances in the field and what kind of criteria one should be looking at. Um, quickly about me. So I do NLP research at Bedrock, and related to what Amir said about not using language models. So 2 days ago, we released a feature. And initially, the goal was, I think I would be using 50% of the task to be divided between like GPT-4 and 50% between our own in-house models. And then over the month of development, I realized that it was way harder to work with GPT-4 than I initially thought. And when we finally launched it, it was like 90% using our own models and just 10% GPT-4. I'll talk about that in the next talk as well, but I'll give some context around that later. I also happen to be writing a book about designing LLM applications, and some the early release of this is probably going to be out in the next week or two. So some of the content of this talk is actually related to chapters 3 and 4 of my book. Quickly going on to what I would like to talk about today, and let me know if you want to change the ordering or anything in the agenda. But first, after ChatGPT, so we'll start with ChatGPT as the baseline, and then say after ChatGPT, what happened in the LLM space, and whether we can all agree that GPT-4 is state of the art, more or less. But has ChatGPT or GPT 3.5 has it been dethroned by any of the open source versions? We'll talk about all the different kind of LLMs that are available these days, and also, why I think in any development environment, like if you are in the enterprise or where you need not just use one model. I think a ecosystem of different models, both big and large, are important, and fine tuning is necessary in order to solve a whole lot of tasks that GPT-4 just can't do it on its own. Also talking about another question that I get a lot, which is like the build versus buy conundrum. And finally, like how to choose your LLM. So I know a lot of people like to use dating analogies whenever it comes to choosing something. But no, this is definitely not like dating, I would think. But I would like to focus on two things, like the nature, or that the model architecture itself, the tokenization, the vocabulary, etc. That the learning objective, as well as the life experiences or the nurture, in which case this is the pre-training data set that is used to train the LLM. So I think that looking at these two these two things can help you, make some kind of informed decisions, along with other like obvious decisions, like obvious criteria like cost, inference, latency, and everything. So talking about So how do we know if ChatGPT has been dethroned? There has to be a robust way to evaluate it. And currently we have like this different types of evaluations. I think the most, I guess, comprehensive evaluation comes from Elo AI, who have this LLM evaluation harness. And you can see there are like a lot of different tasks. And so they have like even tasks related to ethics. Then there are tasks related to biology, chemistry, etc., and so on. And if you look at like their GitHub repo, one thing they talk about is how to ensure that there is the test set is decontaminated, or that the whatever you are evaluating here is not present in the training set already. And then for that you have like this 13 gram uh, 13 gram 13 gram sequences, um, which by the way is also what OpenAI used when they built the original GPT-3 to ensure that the test set was decontaminated. However, this is not really a very robust way to ensure that there is absolutely nothing in the data set. In many cases, you just have to see manually. I guess you have to manually search the pre-training data to see if your test sets have had any kind of training contamination. But yeah, so a smaller version of the a more limited version of this open Elo AI evaluation harness is present here in the Open LLM leaderboard by Hugging Face. And I think this a lot of you might have already seen. And this is where like people say, oh, okay, Falcon is number one. We should use Falcon. But to be honest, it doesn't really mean anything. So it's only taking like a few tasks. I don't know how. So you can see it's just 4 tasks from the Elo AI evaluation harness. So for example, MMLU is the multiple choice question answer and so on. So look at this. It's grade school science questions, common sense inference, and so on. None of which are like really representative, and it's definitely not something that you can say take the average of 4 numbers and say model Falcon is better than model Guanaco or Llama, etc. So that's a evaluation is definitely a problem. Also, the way how you calculate these numbers, there are so many different ways, and just calculating it slightly differently will make the results look a whole lot different. So Hugging Face released something where they found the discrepancies within different kinds of calculations. So for example, you can calculate like this. So there is the question, you pass it through a language model. Note that this is multiple choice. So you have A, B, C, and D. And then you find which of these A, B, C, and D has the highest probability. And then you take that and say, oh, okay, the model is correct or the model is wrong. But on the other hand, you can do it in another way, where you can use from the model, you use a generation by using you select the next token and then find what the next token is. And then there is one more place where you actually try to generate like the sequence containing the answer and see how easy it is, how close it is to the full answer, and you get different numbers for different types of calculations here. So anyway, so it's all pretty complex. There is another one called Helm, by the way, which I think they have a little more robust. So for example, question answering, you have like accuracy, you have calibration, robustness, etc. So it looks a lot more kind of holistic. By the way, you can see OpenAI leading here. But anyway, even this has its own limitations. Again, automatic evaluation is just not possible. So there's this very interesting thing where they use Elo ratings, or if you know, like chess, that's where, like for chess players, they have very similar form of rating where it's you pit one model against the other, and if one model is, and then basically you match them against each other, and then a user, like an actual human being, in this case, it's like the chatbot arena Elo, 42K anonymous votes. So they are shown to, and you have to choose between one model, and then if the better model wins, the model that was already better from a lower ranked model, then it gets some points. If it defeats a much better model, then it gets a lot more points, and so on. So you can if you aren't aware of Elo, you can Google for it, and you can see here it's like, okay, this looks more in line with the like expectations of you using those models. Like we all know, like GPT-4 is looking better, and if you look at open source, like a fully open source Apache 2.0, you have to go back all the way until this. So it's pretty far down the ladder to get to your like first open source, fully open source one. So you have again here MPT, which is somewhere here, but note that this rating is basically, it's not logarithmic, but it's kind of like that, because if, for example, if it is 1200 and someone is 1000, then it more or less means that if you put them, if you pick these two models together, like against each other, around 99% of the time or so, GPT-4 is going to win. So the differences here are actually like going to be quite significant. And imagine like further down the line, you have things at 800, etc. So you can see that it's quite a far way. But again, this is human rated. So is this still believable? Can we still say, okay, Vicuna is better than Open Assistant Llama or anything? So again, like humans are biased and we prefer style over substance. So maybe GPT-4 is telling you a lot of nonsense, especially like my company is in finance, and I see it confidently stating a lot of nonsensical things in finance, which might look on the surface, it might look very intelligent, but it's actually not adhering to any robust financial concepts at all. But people might just prefer it just because it looks cool and it's written in a very authoritative way. Humans also have a bias towards like the first answer they see or a longer answer. Very interestingly, just today, there was a paper about this that came out like just today. Style over substance evaluation biases for large language models, and they propose something called as a multi-Elo rating system, which basically looks, you do Elo but across multiple dimensions. So across accuracy, helpfulness, language. So you can see here. So yeah, again, as you can see, it's really hard to directly say. We need AGI in order to like automatically evaluate these LMs, which is not possible. One way that I do, or like we do it internally at Bedrock, is we have our own test bench. If some of you have attended my talk last year, I talked about this task. That's an example from my test bench. So note that this is not the actual task. So because we also use all kinds of chain of thought prompting, etc. But basically, this is the street orientation of a city. You have this is basically the city of Toronto. You have street from north to south, and you have street from west to east. But when I give it to GPT-4, I actually jumble it. So now that so now I'm testing GPT-4 whether it's actually memorizing, because from its memory, it knows that College, Queen, Dundas, King, these are the streets in Toronto, and it knows which one is north of which. But I have changed it. So if I'm giving directions to go from place A to place B, is it going to pick it from its memory, or is it going to follow my directions? And is it going to give the actual directions? So it's testing both, whether it's able to suppress its parametric memory in order to look at my prompt, and also reasoning and planning. So basically, it's seeing whether it can actually give the right directions. And so far, it isn't able to do it. Yeah. Anyway, so talking about LLM augmentation. So now that we know that it's really hard to evaluate LLMs, let's see what kind of you know LLMs that we have. One thing that we have been seeing in the last several months is the pre-trained model, which henceforth we'll refer to as base model, is now augmented in several different ways so that it becomes easier to use. The original GPT-3 released in 2020, it was a base model, and it was like a teenager, where a teenager is someone who is intelligent, but also someone who doesn't like following instructions. So you needed a lot of prompt engineering, or the more accurate word would be prompt tinkering or prompt hacking, to get something out of GPT-3, which is why we didn't see a lot of production level applications. But now you have these augmentations. There are a lot of different types of augmentations. One is instruction tuning. So one kind of instruction tuning is chat tuning, specifically for becoming a chatbot. Instruction tuning is so that it helps the model easily follow human instructions, so that you don't need to give very weirdly worded prompts. The other is long context models, which I'll get into a little later again, where you can have a larger context window. And then domain task adaptation, so where it is fine-tuned on a particular domain like finance or a particular task. So when I come to instruction tuning, there are like a lot of different types of data sets. So there is like the OIG. One example is the OIG data set. This was actually done for a lot of this was used in a lot of models, including Red Pajama, and this is how it looks. So for example, if you go to Hugging Face, you can see the dataset Weaver, and a typical instruction following dataset looks like this. So human something something, and then so this is in the form of an instruction that a human would write. This is how you would prompt in real life, and then you have like an answer, and then again human and answer. So this is basically automatically generated by using. So the original data set would have something like this, and then you generate a question for which this is the answer, and basically that's how this was generated. But there is other things like Flan V2 is also the Flan collection is also a very popular instruction tuning data set, which uses a lot of traditional NLP data sets and converts into like this kind of an instruction format, where instruction format is basically human giving instructions in English, and then the answer being provided in a way that the humans would like. So yeah, so let's then talk about, like, I don't want to give like a huge list of, I mean, many of you or the earlier talks might have already gone through this, but there are a few kind of types of this model. So the original one is llama, which is when people started saying, oh wait, we can actually beat chat-gpt or GPT-4 with open source models. A lot of people, there is a lot of discussion about why llama is so good. So one of the things is, language models were severely undertrained for quite a long time. So that means that for a particular model size, you could have actually trained them for a lot more tokens and have seen a huge performance increase, but people were just not doing it. And llama was the first one to do it. I think it's a trained the model for like 1 trillion tokens, if I recall correctly, and that's the main reason. So I think there are many people who also say, okay, it's also the data set and the data set cleaning. It's hard. These are all like really open questions because there has not been that much experimentation done to evaluate all of these different decisions that you have to make when pre-training a language model. It's also very expensive to do these experiments because many of these can be observed only at a much larger scale. So then you have like the llama variants. So alpaca is coming from, so these are taking llama and then augmenting it with the instruction tuning data set. And these differ by the way that which they do the thing. So alpaca comes from chat-gpt generated instruction tuning. So you take a seed of, I think they took just 175, hand-coded instructions and their answers, and then asked ChatGPT to do the rest. And ChatGPT generated like 50,000, and that was the alpaca data set. And then there was Vicuna. Vicuna basically used actual human logs of their chat conversations with ChatGPT and used that as an instruction data set. Guanaco, they used parameter efficient fine tuning LoRa. So they, instead of doing full fine tuning, they only did for a small subset. So number 3 is something interesting. So these are pre-trained from scratch by companies who, I guess, have a vested interest in people using LLMs a lot more. So either they could be like companies in the ops space. So Databricks is the one behind Dolly. Mosaic ML is the one behind MPT. Cerebras is the one behind Cerebras GPT. But basically, they would benefit, if there are more people running inference on LLMs and so on. So these have more, permissive licenses. The ones at the bottom, they are coming from, like, so some of them are now companies. So Red Pajama is now together, which is a company that I guess got 20 million in funding recently. MDEL is one that I am kind of involved with, which is basically using mixture of experts to build a language model that can be on par with GPT-4. But how to choose this, we'll come to that next. So talking about like the inevitability of fine tuning. So in a lot of cases, I guess, yeah, okay, let me give you an example from my work. So in finance, there is the concept of business segment. And business segment, for example, AWS is a business segment of Amazon. But there is also the concept of user segment. And user segment is, college educated person, divorcee. It's a particular demographic. And one thing I noticed is that GPT-4 zero shot conflates those two concepts. It doesn't understand the difference between the two, and it oftentimes it confuses between them. So how do I solve this? If I'm working on a particular financial task, you could say, okay, let's add it in the prompt. Sure, you can add it in the prompt, but there are like thousands of different financial concepts that you need to do it. How many things can you stuff it into the prompt? That's not possible. So um, there's no free lunch. So long context support comes with trade-offs. So for example, I think you might have seen there's this. Okay, there was this recent paper, LongNet. There have been papers in the last 2 years. Many of them were promising, okay, we can scale up to 1 million tokens. But again, there is no free lunch. You can't. There is a trade-off involved. So there was a paper that came out just yesterday that showed that in your prompt, the text at the beginning of the prompt and the text at the end of the prompt for decoder models, that's where it has the highest level of retrieval or recall, like the language model. But the language model, oftentimes, it forgets things that are in the middle of the prompt, especially for decoder models. You don't see that similar effect for encoder decoder. I'm not sure if I have this on, but I can put it in the chat later on. Like, I don't know if I have added this paper. Yeah, I think I haven't. But I can put it. So yeah, going back, what it means is, you have a limited context, and you can give only a limited set of instructions per input. So you can't fit your prompt. So I have noticed that, for example, we were trying to do something with prompting, and eventually it was just like 5 instructions, and then we realized there are so many edge cases, so we just kept adding instruction and instruction and instruction, and then we realized, oh wait, it's not able to follow all instructions. Once you reach like 25 instructions in a single prompt, it's going to forget to do a bunch of those. So and the second thing is, hallucinations. Again, there are people who say, oh, we have like really cool prompting scheme, we have invented something cool, and that's all nonsense. You simply can't do it. It's an unsolved problem. So you can't. There is no way that you can prevent a model from getting something from its parametric memory. Even you can't just say, oh, hey, look at, only use the information provided in the prompt. No, it doesn't work like that. So that's why, and I think companies will eventually have to use fine tuning, but they will have to. You can. I'm not saying that in context learning never works, but you have to basically divide your problem in such a way that there is space for both. So the way I see it, and the way that we did it for the most recent product that we launched. So GPT-4 is not a finance expert, but our custom models are, because we pre-trained it on financial data, on a lot of financial data, on millions. Actually, it was several dozens of billions of tokens of financial data. So let the smaller LLM, and by smaller LLM I mean anything starting from BERT all the way up to 40 billion, or maybe 20 billion. Anything that can fit in a single A100, I would say. Go ahead, do the task adaptation, domain adaptation, retrieval augmentation, everything goes there. There are certain things that the smaller LLMs just cannot do exactly. So some kind of abstract reasoning, again, it's a very restricted form of reasoning. GPT-4 isn't good at reasoning, like there are many pitfalls, but you can somehow isolate what kind of reasoning you need for a particular task. GPT-4 is also very good at wordsmithing. So currently for our product, I'll tell you what our product is. The most recent product is doing a very effective form of long document summarization. So you take a document that can be hundreds of pages long and then summarize it in just 1 or 2 pages. It's a very, very difficult task. And because there are literally like 10 criteria that you have to balance against, and all of them are trade-offs. So you have to balance structure, you have to balance completeness, you have to balance factuality, you have to balance length, you have to balance, relevance, and so on. So and you just try to improve one in one direction and you see it regress in another direction and so on. So the way we ended up doing it, and where GPT-4, as mentioned in the beginning of the presentation, is giving like the 10% lift at the bottom, it's in the wordsmithing part. So we have our smaller model do everything. So we have it select the content, we have it choose the topics, and then we give this to GPT-4, and when we ask it, okay, GPT-4, convert this into bullet points. And bullet pointed text has a different kind of literal, a different kind of writing style, right? It's not something that any of the smaller models can do. And also the other thing is taking information that is in 5 sentences and putting it into 1 sentence. That's also something that GPT-4 does really well. So for example, I think we generated the sentence for Meta, the company Meta, and it was so beautiful. I almost cried. So there were 5 different sentences describing what Meta is, and then GPT-4 said it include in a single beautiful sentence. It said, okay, it used to be called Facebook. It's a social media company. They make money through ads, and then they are also leaning into the metaverse. So all of these, so within a single sentence, that doesn't look too unwieldy. It's very hard for a human to do that. I mean, it is possible definitely, but the way that you can do it in automated way and at scale was like really, really nice. And again, if you have like really well-defined low-level NLP tasks, you have to do entity extraction, and then you don't already have like a pipeline setup. Again, you can use this LLM. So again, how to choose your LLMs? Again, all of these: cost, latency, flexibility, uncertainty, estimates, debuggability. So for me, the most important is flexibility and debugging. So when I look at a language model, there are a few things that I would like to see. I would like to see the token probabilities. But if you use GPT-4, you don't get that. If you use chat-gpt, GPT 3.5, you get the log props, but you get only the log props of the top 5 tokens. So it's very hard to like debug. And for some of the closed source APIs, you don't even know what the vocabulary is. Like you can reverse engineer the vocabulary, but you don't have it available beforehand. So yeah, I mean, it really depends on but I think those are all useful factors that you need to take into account. So let me then talk about like the 2 main things. Like I would like to talk nurture and nature. So what the pre-training data set is. So if the pre-training data set is closer to your target domain, then there is a better chance of that model, all other things being equal, because there are other things that affect how good a model can be, like for example the model capacity, how they clean the data, the training, whether the number of tokens that they trained on, etc. But everything else being equal, like if you have a data set, if the pre-training data set has something that you are already using, then that would be nice. So for example, the Washington Post, they have this thing, websites in Google C4 dataset. And we found that, for example, Motley Fool, no, sorry. So in finance, there's something called as the fool.com, and it's ranked 13. So that means out of all the websites in the world, this website contributes like the 13th highest to C4, which is the data set which was used to train T5 family of models, but C4 is also used in a lot of open source models as well. So a fun fact, Block 2 is somehow in one of the top ranked, and so it knows a lot about Toronto streets, a lot of these open source models. So, for example, if you're using Bloom, you can use something as roots. And I just, for example, why are these models, why do these models know how to give directions from place A to place B? And that's because the training data set contains it. So you can see here, for example, Jarvis Street begins at Queens Quay and then north of Front Street. So you can see that there are so many documents that are just talking about directions. So it's no wonder that it's able to give directions. So this is like probing pre-training data sets gives you an idea of how much it is likely to, how much something is already present in its training, in its pre-training. So let's, for example, look at, Amir, who is the host and organizer of this event. So you can see that Amir is part of C4, so a lot of language models actually know about Amir, but maybe his past life, because it looks like it's all about hardcore physics. But yeah, so that's something you can have a look at. The other thing is whether they have, cleaned their data in a particular way. So recently, you have seen many models that have said, okay, so we have come up with a better model. And the difference is that we have cleaned the pre-training data set more rigorously. An example being refined web, which is basically the model that's part of Falcon. Give me a second. Yeah, I was just making sure that everyone is still here. It looks like people are here.
It's very quiet. We are very absorbed in the talk.
Yeah, I wondered if the call got cut off and I was just speaking to myself. But yeah, so there is refined web, which is basically Falcon. So Falcon's claim is that they built refined web, which is a very cleaned version of the pre-training data set, and that's why their model is the best. And then is also Slim Pajama. I think that's coming from Cerebras GPT, who cleaned the Red Pajama. I would have been happier if they named it Clean Pajama, but somehow they named it as Slim Pajama. So you can see Slim Pajama. So what do you mean by cleaning? So I cover this actually a lot in my book, the exact cleaning pipeline. But you can see here, this is how it looks. So actually, there is also a whole lot going into this cleaning. So, but anyway, you don't need to read all this, but a lot of the thing that is happening is deduplication. And deduplication is like really, really hard. And there is a lot of, debate in the community whether deduplication is actually useful or not. I think there is a nuance to it. And the nuance is basically, if something is deduplicated, like if it is HTML boilerplate that occurs 20,000 times in your pre-training dataset, sure, go ahead and leave it. But if not, I don't know. I don't think there is sufficient evidence. Like you can put it. There has been recent evidence that shows, for example, you can train for multiple epochs without overfitting. You can train for 4 to 5 epochs without overfitting. This was actually shown last year by Galactica, but a lot of people just ignored the Galactica paper for various reasons. But anyway, so step 3, deduplication. So you can go through this. It's a very involved process, but basically you can have deduplicating involves both approximate deduplication and exact match deduplication. Deduplication can happen at the sequence level, but it can also happen at the document level. It's very, very computationally difficult, and you need to use like all these hashing algorithm, min hash, LSH, locality sensitive hashing, basically, to do this. Yeah, so that's that. And then if you look at it from the modeling side, you can see that you have to, for example, tokens. So Galactica has special tokens for representing, I guess, amino acid sequences. So let me show that here. And I think, yeah, so since we are getting to the end, I think I'll stop it here. But let me just show you the Galactica. So going back to, the long context, again, people keep asking me, hey, the long context, is it working or not? And, it's not really that simple. If I give an analogy, so you can see my browser, it has this many tabs open, right? And like a normal browser has like 10 tabs open, and you can think that I'm using long context because I have so many tabs open here. And then I'm like, okay, I'm going to go even further. I'm going to extrapolate it to millions of tokens. And the way I do it is, so for example, this is one window, but I have another window here with the same amount of tabs open. And I have 2 more windows here with the same amount of tabs open. So you can see that I have like over 1,000 tabs open. But what's happening is, I have now lost the ability to retrieve, because earlier when it was just a single window and maybe 80 tabs, I had like exactly memorized which tab is which. And so I can get easy retrieval from that. But now I don't know which tab is, in which window and what each tab represents. Or, I mean, I have started forgetting it. So similarly, you can see that, long context, it's just, you don't gain, it's just not, especially the way you are doing the long context, whether it's through dilated attention or whether it's through, using your alibi style positional embeddings and so on. So it's pretty hard. Yeah, anyway, I think I'll probably stop now.